folks, this is Sid here. Sorry this is going a little later than expected. Ran into some family busyness yesterday, evening and afternoon. So here we go. It's Saturday afternoon. I'm finally able to sit down to do a video for you. So last time we actually met on Friday, we had talked about the domain of a composed function, and there were a lot of questions in both classes about this. So I thought I'd start over with example 2. I'm not sure if it'll help folks or not, but I figured it's worth the shot. So I'm going to walk through those 3 steps. Actually, before I even do that, let me do some work off to the side. So some things you really need to look for domain. I would say when I'm thinking about domain, I assume from the start all real numbers. Okay. And things that I look for where I know this is going to change is I look for a square root because that's going to change my all real numbers. Or the other thing I look for is division because that's going to also change that from all real numbers. So let's talk about this. If I have a square root, whatever is underneath the square root, whatever that is, it has to be bigger than or equal to 0. If you think about our parent function, y equals the square root of x, our domain is 0 to infinity. 0 is included, so that's what I'm saying equal to. So whatever is under there, if it's x plus 1, then x plus 1 has to be bigger than or equal to 0. If it's x squared minus 5x, that's got to be bigger than or equal to 0. Whatever is inside that square root, it has to be bigger than or equal to 0. So that would be something that would definitely throw a wrench in this all real numbers situation, because now we have something that will restrict our domain. So the other piece that I look for is division, and specifically whatever's in the denominator. If I have a denominator with an x in it, then I know that denominator cannot equal 0. So honestly, I kind of solve whatever's in the denominator. I solve it like it does equal 0. And then I find those values and I say, okay, I want everything but what I just found. So those are really the 2 places I look for when I'm thinking about domain that could change things. And if you take a look in problem 2, we ran into that square root issue. If I scroll down in problem 3, we're going to run into the division issue. So those are really more exciting domain problems because things can change. All right, let me go back now and redo problem 2. I'm hoping this will help some folks. So we want to find f of g of x and give its domain. So the first thing I need to do, according to my steps up above, is find the domain of the inside function. Inside function here is g. Well, hey, look at that. G of x is a square root. So it falls under one of those cases that I was talking about. So over here, I'm going to take whatever is underneath the square root, exactly how it is. I know some folks were asking, why don't you take the square root of 9? It doesn't matter that that's a 9. It could have been a 10 or an 8. The fact is, it's just a number under there with an x. So I'm just going to take it as is and say that has to be bigger than or equal to 0. So now I have an inequality I can solve. So I'm going to subtract 9 from both sides. And then dividing by -1 flips my inequality sign. So right now, it's looking like my domain is -infinity to 9 because x has to be less than or equal to 9. So that's really that step 1 up in the box. All right, step 2 says to actually do the composition. Let's do that over here. So step 2 means I'm going to put my g function into my f function. So this is going to look like f of that square root. Okay, so that square root's going in everywhere I see an x. So I'm going to do that square root squared plus 5. Now that's that hard step that I've been talking about in class, substituting in that square root of 9 minus x. From here, we're going to do some simplifying. So I see that I have a square root being squared. Those cancel each other out. So I'm really looking at 9 minus x plus 5. So I just have to combine my like terms. And I get 14 minus x. You can also think of it as negative x plus 14. Either way, that doesn't matter. So that's our composed function. Now, before we leave step 2, it says find the domain of the composed function. Well, again, I'm starting with the assumption it's all real numbers. I don't see a square root anymore. I don't have division, so there's no reason to say that it's not all real numbers. So the domain of the composed function, it looks like to be all real numbers. So now I have to take the overlap. Well, if you think about it with number lines, I know I did this with 7th period, 6th period, this might help some of you folks. If I think about this all real numbers, so the result says all real numbers, that's just the whole number line colored in. And then I think about this less than or equal to 9, it's going to look like this. Now I have to find the overlap because that's going to be my answer for the entire domain. Well, they overlap here. So my overlap is negative infinity to 9. Right. I hope for some folks that talking about this first maybe helps. I think I dove into domain without really discussing the fact that we have places in domains, we have places in some functions that restrict our domains. In other words, it's not all real numbers. Okay, let me go to the one that has division in it. All right, number 3. Notice it has 2 parts. One is composition, and one's division. I'm going to draw a line between the 2 parts just so I can have space on either side. And let's take a look at what we have here. Step 1 is find the domain of the inside function. So inside function is going to be our f function. So step 1, well, look at that's division. So its domain is going to be all real numbers except 0, because we don't want 0 in that denominator. So how do we write that in interval notation? Well, we pull out lots of parentheses, and we say negative infinity to 0, and then put a parenthesis and do union, parentheses, 0 to infinity. All right. So I hope that makes sense that we can't have 0 in the denominator there. Let's go on to step 2, which is actually doing the composition. So I'm going to put this in here. So f of g of x, oh, I just wrote that wrong. That should be g of f of x, sorry about that. So this is g of 2 divided by x. So this is going to be 5 times 2 divided by x minus 20. So again, that's that hard step, what I've written in step 2 to go here to step 3. Now I'm just going to simplify. I'm thinking of this as 5 over 1. So that means this is really 10 over x minus 20. So I get 10 over x minus 20, because I get 5 times 2 over 1 times x. Okay, so that's going to be my answer for up here. 10 over x minus 20, that's the actual composition. And before I leave this composition, I have to think about its domain. So I don't have a square root, but I still have division. And notice that the domain of this guy, just all on its own, is negative infinity to 0, union 0 to infinity, meaning all real numbers except x cannot be 0. Well, good thing is that's the exact same domain as we had in step 1. So in step 3, to find the domain of the entire composed function, we take the intersection of those two, but they're the same. So our intersection is pretty easy. We don't need a number line for that. It's negative infinity to 0, union 0 to infinity. Okay. So to help with the domain a little bit, I think that this division problem will be interesting. Now, because it's division, we don't have to go through the 3 steps in determining the domain. We're just going to look at the result and say what the domain is based on the result. So let's dive in. Remember, this is saying f of x divided by g of x. So we have 2 over x divided by 5x minus 20. Okay, so this might take you back to middle school or junior high when you learned how to multiply and divide with fractions. So I'm going to think of this as 2 over x. Instead of division, I'm going to say times, and I'm going to take the reciprocal of that denominator. So 1 over 5x minus 20. Now I can multiply the fractions across. So I get 2 in the numerator, and I get x times 5x minus 20 in the denominator. And so that's going to be my answer for the division. If you would prefer to distribute the x and call this denominator 5x squared minus 20x, you totally can. That doesn't bother me at all. I'm keeping it factored just because that's going to help with domain. So this is another fraction, so we have to think about what values are in the denominator. So whatever x times 5x minus 20 is, it can't be 0. So if I think about, hey, well, why don't I find where it does equal 0? That's going to help me figure out the domain. So since this is being multiplied, I can use 0 product property. So I get x equals 0 or 5x minus 20 equals 0. So let's solve this second branch a little bit. So 5x equals 20 and x equals 4. So because this is really what I don't want to equal, I know that I don't want x to be 0 and I don't want x to be 4. So for a final answer for my domain, I'm going to have a lot of intervals. It's going to start at negative infinity, go to 0. Remember, 0 is not included because we don't want 0 in the denominator. 0 to 4, union 4 to infinity. So basically, I'm saying all real numbers except 0 and 4. Again, I didn't have to go through that 3-step process because this is a division problem, not a composition problem. Okay, so I hope that helps a little bit for some folks who were confused on Friday. I do want to kind of finish off this worksheet so you can see what we would do if we had the graph. So these are kind of fun for, I actually find students like them too, because you're just reading the graph and seeing values. There's not a lot of work to show. So let's take a look and we'll do a few of these and see what happens. So this is f of g of 0. So first I want to do g of 0. So I go to my g function, I see g of 0 is 0. So now that output of 0 on the g function, or the y coordinate on the g function, becomes the input on the f function. So now I'm going to go to the red line, f of 0. Well, that's just 2, because I'm looking at this point right here. Okay, so let's take a look at another one. Let's do g times f of 0. So this is really g of 0 times f of 0. So again, I go to my g function when x is 0, looks like y is 0. And then f of 0, we actually found that in the last one, that's 2. But 0 times 2 is 0. Okay, so far we've been using the same point. So definitely let's do a few more just so we can have some variety here. So this is saying do f of 4 and add g of 4. All right, so we're definitely not going to get a 0 here. So f of 4, I go to 4 on my x-axis and go up. Oh, that y-coordinate is 4. G of 4 looks like 2. 4 plus 2, 6. Let me do one more before I leave you with this video. This is f of negative 2 minus g of negative 2. So if x is negative 2, let's see, f of negative 2 would be right here. So that's 1. And then g of negative 2 is nothing. It's like undefined. So what in the heck do we put for our answer? Well, I'm just going to say no solution. Definitely can't do this because g is not defined. It doesn't have anything for its domain at negative 2. So we're just going to say, you know what? Bad question. Not a good one at all. Let me see if there's any other good values. Seems like not really. So I think g of 4, or sorry, part C here, the second part C, f of g of 4 should work out because we already have values for 4 when x equals 4. And then g of f of 0 is definitely going to work as well. Well, actually, let's look at this one because this one might be a little interesting for some folks. All right, so let's do f of 0 first. So f of 0 is this 2 value we've been using in a couple other problems. So I'm going to take the 2 and I'm going to input it into my g function. So now I'm looking at g of 2. So here's why this is interesting. That's not really a value, is it? Although looking at g, it looks like it's the square root graph, so I'm guessing this is just the square root of 2. Now, guessing doesn't feel so good, especially when you're on math. So you might be asking yourself, is this something we're going to have on our test next week? Would I give you something where you had to guess at the value? No, that is definitely not something I would give you. But it looks like for this problem, we're going to land at a square root of 2. So I hope that helps. Do look for a review coming your way. I'm hoping to get that up before Monday, so if you want to start working on it, you can. I'm also going to start looking at homework number 6, I believe, whatever the last homework is that folks turned in, because I know that's piled up, so I want to get those grades and feedback back to you. Please reach out if you have any questions. I hope this helps. Rewatch if you feel like you didn't get it the first time around. All right, see you folks on Wednesday.